Hello, everyone. Let's take a look at number 3. Jeff is considering borrowing $12,000 to enroll in a semester of university, but he's having trouble deciding between the two bank offers that he received. What should he do? Step 1. You can do it. Have the belief that this is very doable as long as you understand the formula. So step 1, self-belief, you can do it. Step 2, if I zoom into the first table, here's the information about the first loan offer. The loan amount, which we're going to denote using capital C, is going to be $12,000. The second piece of information is the annual interest rate, which is 3.5%. Now, how do we use that number to calculate the monthly interest rate? So R equals to, again, if you think about 3.5% as a decimal, that's going to be 0.035. And because we're talking about monthly interest rates, it's going to be compounded monthly. So we're going to divide this by 12. So again, I'm just going to put it one more time, just into the right spot, just like that. So don't work it out yet. When we do use the calculator in a moment, we can do all this in one step. Number of months, N. So it does say 72, but the way I infer this is really 6 years, because if you think about the compounding frequency, which should be compounded monthly, is 6 times 12, which basically becomes 72. Now, what about the monthly payment P? Here comes the formula. Are you ready? You got this. So according to the formula, P equals to C, which I'll put in brackets, times R, which I'll put in brackets, times 1 plus R to the power of N, and I think they use capital N. So I'm going to follow the same formula, divided by 1 plus R to the power of N minus 1. Now, before we even plug it in, I'm going to give everybody a warning. You got this, and make sure you put brackets, because I don't know which calculator you're going to use, and I want to make sure that we get the same answer in a moment. Now, if we go back to the loan amount, we wrote down 12,000. And R, again, is going to be 0.035 divided by 12. Again, put the brackets around each number. Multiply by 1 plus 0.035 divided by 12 to the power of 72. Again, I think about it as 6 times 12, which is the number of payments, or the number of periods, I should say, which is 72, divided by, again, 1 plus R, which is 1 plus 0.035, divided by 12, again to the power of N, which is 72 minus 1. Don't forget these brackets. I'm going to put them at the top and at the bottom. Now, please don't eyeball this. Make sure you have a calculator. Make sure you have a piece of paper and a pencil. You and I, one team, one goal. Let's try this. So I'm going to do this with you in real time. Let's see what happens. 12,000 times 0.035, divide this by 12, times open bracket 1 plus 0.035 divided by 12 to the power of 72. I'm dividing by the bottom. I'm opening two brackets, 1 plus 0.035 divided by 12 to the power of 72 minus 1. And in the display, I see the following number, 185.020765. Now, be mindful. There are two rounding ideas that you would like to think about. First of all, when it comes to money, we only talk about the accuracy up to 2 decimal places. But the second rounding that you want to think about is in the Canadian currency. We don't talk about pennies anymore. So really, it's going to be 185.00. So in terms of the answer, that's what I would say. If you want to use this number to carry forward to the next calculation, then I would say, 0.02 is good in terms of maximizing the accuracy. But again, you got to follow your teacher, right? This is kind of the general rule. So I'm going to go back, write down 185. Now, what about this next part? Long-term costs. So according to the given, N stands for the number of months, which is 72. According to the given, monthly payment is P, which is 185. So I'm going to copy 185.00. Now, again, because I know I'm going to use this to multiply in a moment, I am going to use 185.02 to maximize the accuracy. But again, please follow your teacher to maximize your performance. So N times P is going to be 72 times 185.02. Now again, let me try this with you here and now. So 72 times 185.02. So on my calculator, this works out to be 13,321.44. And of course, what is the total interest paid? So I follow the formula, n times p minus c. And n times p is 13,321.44. And I subtract c, which was the initial amount. I think it was 12,000, right? There it is, 12,000. So I'm going to go back, write down 12,000. But really, you can write down just the answer. Sorry for the mess. Let me subtract. And I get $1,321.44. So that's the first half of this example. Now, what I would like everybody else who's listening right now, press pause, try loan offer number 2. Go through every single calculation. Press pause, try this, and when you're done and you press play again, I'll be here. Welcome back, everybody. Here we go. We're starting with the loan amount of $12,000 again. Notice this time the annual interest rate is 3.75%. So before we keep going, I would like you to think about this using common sense, even though common sense may not be common action, but think about it from a common sense perspective. Use judgment. The fact that it's going to be 3.75%, the gut feeling tells me, well, it's probably going to be more in terms of monthly payment. Then think about the fact that it's 60 months versus 72 months. Think about that, use critical thinking, and we'll come back to this at the end. Now, again, what is the monthly interest rate? R equals to, again, 3.75% as a decimal is going to be 0.0375. You can always divide that by 100 if you want to double check. And we divide this by 12. So think about it from the perspective of compounded monthly. Same idea, even though they gave us the number of months, which is 60, the way I understand this, the way I infer this is 5 times 12, which is basically 60 months. Again, what is the monthly payment? Let's try this one more time. So I'm going to go back. I want to make sure you can see how this is very similar, right? I'm following the template. So I take C times R times 1 plus R to the power of N. And I'm going to use capital N just to follow your formula. I'm putting brackets around everything else. Divided by 1 plus R to the power of N minus 1. Again, please don't forget this bracket. A lot of students understand the concepts, but they don't get the same answer, and they're panicking. But no one should be left behind. So again, I keep going. I go back and I recognize in this case, let me zoom in for you. We're looking at 12,000. And when it comes to the interest rate, it's going to be 0.0375 divided by 12 times 1 plus 0.0375 divided by 12 to the power of 60, all over 1 plus 0.0375 divided by 12 to the power of 60 minus 1. Again, don't forget these brackets, it matters. Now, I'm going to try this with you in real time. I don't know what the answer is, but my gut feeling, my common sense, my educated guess tells me the answer should be larger than 185. Let's find out. So I take my calculator and I'm working it out. I hope you're doing this with me in real time. Do not just eyeball this. You have to wire your hand-eye brain coordination because we're neurons fried together. They wire together. So I'm almost done the top. I divide this by the bottom, open two brackets, 1 plus 0.0375 divided by 12 to the power of 60 minus 1. Now, in the display, I see the following number, 219.6470199. As you can predict, there are two rounding ideas you would like to think about. First of all, 2 decimals. Second of all, to the nearest penny, because we only talk about pennies. Sorry, not to the nearest penny, to the nearest nickel, or to the nearest dime. But again, you just got to follow what you do in class. I'm going to go back, write down 219.65. 219.65 in the box. Again, the rest of this, very systematic. The number of months we knew was 60. Monthly payments, we calculated to be 219.65. Then we multiply N and P. So again, 60 times 219.65. Let's work it out. 60 times 219.65. Now, this is going to be $13,179, and I'll put 0.00 just to show you the decimals. And I got to take that amount minus 12,000. I'm not going to write it down this time. I hope you're following. And this is going to be $1,179. It's too much for you? So I hope this makes sense.